Hello, welcome back to Learn Physics. In today's topic, we are continuing with the same chapter, that is electric charges and fields. Okay, so in this video, what and all topics which I am discussing, that will be the revision for this chapter, because last day itself the theory portions are over, and there in that video I had given you some check your concept questions. Those questions I will be discussing now, and along with that I will be just revising everything which I told you in this chapter. Okay, so shall we start? The first question was, the electric field components due to a charge inside the cube of side 0.1 meter are Ex equals alpha x, where alpha equals 500 Newton per coulomb meter to the power minus 1. Ey equals 0, Ez equals 0. Calculate the flux through the cube and the charge inside the cube. So in the previous day, I did one such kind of question. So this is a previous year question from your CBSE exam. Okay, so exam question paper I had taken this questions. I think you would have done that. Okay, because it was just like the question which I taught you in the previous video. Right. So those who didn't watch the video, please try to watch those videos. The links are given in the description box. Okay. The electric field components due to a charge inside the cube of side 0.1 meter are Ex equals alpha x, where alpha equals 500 Newton per coulomb meter to the power minus 1. Ey equals 0 and Ez equals 0, and calculate the flux through the cube. So we should find out the flux and the charge inside the cube. Okay, so here the diagram is, this is a cube and this is x, y, z axis, x, y, z axis. Each side is 0.1. From here to here it is 0.1 meter. Okay, so this is the question which is given in the question and the check your concept questions. Okay, so here we should find out the phi. So in yesterday's video I explained about such kind of questions. For finding out phi, what we should do, phi equals E dot ds. Right, so from that we can find out q, because phi is equal to q by epsilon 0. Q equals phi into epsilon 0. For that, first we need to do is phi equals E dot ds. For all the sides, we should find out the total flux linked with the circuit. So here already it is given Ey equals Ez equals 0. So phi along y axis is phi along z axis will be equal to 0. Now we should find out phi along x axis only. Okay, so for that x axis we can consider here also 1 and here also 1 is there. Flux is acting out. So right, so x is Ex. This is the surface area. So here Ex is acting in this direction and surface area is acting in this direction. Okay, so right side and left side. So we should consider phi right side. E dot ds. Right side means E and S are acting in the same direction. So E ds. E is alpha x into S is x square. Okay, next alpha is 500. X is 0.1 into 0.1. So x is this 0.1 and here it is 0.1. So here it is 0.2. 0.1 plus 0.1, 0.2 into 0.1 centimeter or meter it is 0.1 centimeter. So you can convert it as x is 0.1 centimeter. You can convert it into meter. 0.1 into 10 to the power minus 2 meter. You can convert. So here 0.1 into 10 to the power minus 2 the whole square into 10 to the power minus 2 for this point 2. Okay, how this point 2 is getting this point is right side point is at a distance 0.1 plus 0.1 together at a distance of 0.2 meter. So 0.2 into 10 to the power minus 2 we are considering. Okay, this is for 5r. So here we will get it as 100 into 10 to the power minus 1, 10 to the power minus 4, minus 6, minus 7. Okay, unit is Newton per coulomb meter square. Okay, so next is 5 towards the left side. Left side, how we can find out? E and ds are opposite to each other. So what is angle theta? Theta is 180 degree. So EDS minus cos 180 minus 1 minus EDS. So alpha x square. Alpha is 500, x is 0.1 only. This distance is this is at a distance 0.1 meter. So it is 0.1 into 10 to the power minus 0.1 into 10 to the power minus 2. Minus 2 into 0.1. Okay, so here do 10 to the power minus 2. So while solving we will get it as 500 into 0.1, 10 to the power minus 1, 10 to the power minus 2, minus 4, and here x square, right? So 10 to the power minus 500 into 0.01 into 10 to the power minus 4 into 10 to the power minus 2. Okay, here you will get it as 5 into 10 to the power minus 6 Newton per coulomb meter square. While you are adding these two, you will get the final answer. So left side and right side you should find out. Clear? So here in this is 0.1. This distance is 0.1. This is what you should understand in this concept. And EY and EZ, 5Y and 5Z will be equal to 0. So next is total flux equals 100 into 10 to the power minus 7 plus 5 into 10 to the power minus 6. For that we can find it as, say, 10 into 10 to the power minus 6 plus 5 into 10 to the power minus 6. So 15 into 10 to the power minus 6 we will get. Okay, the unit for 5 is equal to E dot ds Newton per coulomb meter square. Okay, now Q equals 5 into epsilon 0. 15 into 10 to the power minus 6 into 8.854 into 10 to the power minus 12. Okay, while solving you will get the final answer. This is how you should find out. Clear? Next one was a hollow cylindrical box of length 1 meter and area of cross section 25 centimeter square is placed in a 3-dimensional coordinate system. The electric field in the region is given by E equals 50x I cap, where E is in Newton per coulomb and x is in meter. Find net flux through the cylinder, charge enclosed by the cylinder. So for that the diagram is given like same way. Instead of our cube is here, it is a cylinder is given. Okay, so here it is passing through like this, x, y, and this is z. This is x. Okay, here it is E1 is acting in this direction and here E2 is acting in this direction, and this is 1 meter and here also it is 1 meter. We should find out E equals 50x into I cap. Okay, area of cross section is given as 25 centimeter square and length is given as 1 meter. Okay, so this is how we can find out the flux and charge of this cylinder. So here this is E, which is acting in this direction. E is acting along x-axis. So along y-axis what will be E? E will be equal to 0, and z-axis also E will be equal to 0. right? So only along x-axis E is acting. Now we can find out the here right side and left side. N is acting or S is acting in this direction, here S is acting in this direction. So left side, while I am considering phi is equal to E ds. What is E? E and ds are acting in the opposite direction. So cos 180. What is E here? 50x, and A is given as 25 into 10 to the power minus 2. Right, area is given as 25 into minus 2 the whole square, that is 25 into 10 to the power minus 4. So x is 50 into 1 meter into 25 into 10 to the power minus 4. Okay, 10 to the power minus 4, so we will get it as 0.125. Clear? So this is how we will be finding out the flux. Unit is phi is equal to E dot S, so Newton per Coulomb meter square. Now for the right side. Right side, how we can find out? Phi is equal to E dot ds. E and ds are acting in the same direction, cos 0, 1, so we will get it as E into ds. So same way, 50 into x into A is 25 into 10 to the power minus 4. So 50 into, what is distance here? 1 and plus 1. So this right side is at a distance 1 plus 1 meter, that is 2 meter to 25 into 10 to the power minus 4. So we will get it as the same way, 0.125 into 2 Newton per Coulomb meter square, because 50 into 25 into 10 to the power minus 4 already we did, right? So let it be like this. So total flux will be equal to 5L plus 5R. 5L we got it as 0.125. Here also 0.125 is there, so left side plus right side. Okay, so here it is negative, cos 180, so it will be negative value. So minus 0.125 into 3. So here you will get it as, not here negative, cos 180 minus 1, this is 0.125 is negative. So here we will get it as 0.125 Newton per Coulomb meter square. Right, that now we got the value of phi. Now how you should find out Q? Q equals phi into epsilon 0. Phi value we already got, epsilon 0 value we know, 8.854 into 10 to the power minus 12. Okay, so using that you can find out the final answer for this Q. Clear? So next some JEE level questions we will do. Okay, so a charge Q is distributed to two different metallic spheres having radius r and 2r such that both spheres have equal surface charge density. The charge on larger sphere is. So a Q charge is distributed to two spheres which are having radius r and 2r. So equal surface charge density, that surface charge densities are equal. We should find out the charge on larger sphere. Larger sphere means at 2r. What will be the charge? So here total Q charges distributed to the spheres which are having radius r and 2r. Right, surface charge densities are equal. Okay, sigma, surface charge density, what is the formula? Q by A. Q divided, so I am taking, here it is getting Q charge and here it is getting Q dash charge. Okay, if Q is the charge over there, Q by surface area, what is the surface area of a sphere? 4 pi r square. That is equal to Q dash divided by 4 pi into 2r the whole square. Right, so Q by 4 pi r square equals Q dash divided by 16 pi r square. Clear? So we are getting an equation like this. So here 4 pi r square and 4 pi r square will get cancelled. You will get q dash equals 4q. Now we know q and q dash will be equal, the sum of q and q dash is equal to q, because total charge q only distributed to these two spheres, right? So q will be equal to q plus q dash. So that is equal to q is q plus 4q. That is total charge is 5q. 5q, small q. So what is q here? Because about small q it is nothing mentioned in the question, isn't it? Only about q, r, 2r it is mentioned. This and all we had taken for our simplicity. So q we are getting it as q by 5. So here q dash equals, what is the bigger sphere means it is q dash. Therefore q dash equals 4 into q by 5. Okay. This is the correct answer. Clear? So next one is 3 identical spheres, each having a charge q and radius capital R, are kept in such a way that each touches the other two. The magnitude of electric force on any sphere due to the other two is given as. So which is the three spheres having charges q and capital R. They are arranged in such a way they are touching each other. So one will be touching the other two. So we should find out the magnitude of electric force on any sphere due to the other two. Magnitude of electric force. F is equal to 1 by 4 pi epsilon 0 q1 q2 divided by r square. We should find out. Okay. Net force acting on any one sphere. Charge is same, radius is same. So I am considering the 3 spheres having radius r. They are arranged touching each other. And here, this is here, and this is the center. So this is R, and this is R, and this is R, and this is R. Forces like this. So here this is A, B, C. Okay, so here force is acting in this direction, F, A, C. Since it is Q, Q is the charge acting on each one. Right, here F, A, B. So what will be this angle? This angle will be at 60 degree, right? So this is at 60 degree. So we should find out F, A, B. 1 by 4 pi epsilon 0 Q divided by R square. What is this distance between these two, B and A? This is 2R the whole square. So we will get it as 1 by 4 pi epsilon 0 Q square by 4R square. Since charge and radius are same, the force will be same everywhere, right? So we can write FAB is equal to FAC will be equal to F I am taking. So what will be the force acting on A will be equal to root of FAB square plus FAC square plus 2FAB FAC cos 60. Okay, so root of F square plus 2F square cos 60 is 1 by 2. Okay, so we will be getting it as root 3F square. So the answer is root 3F. So here we can write otherwise as root 3 into 1 by 4 pi epsilon 0 Q square divided by 4R square. This is the F is not in the question, right? So we can represent it this way. Clear? Next is a uniformly charged thin spherical shell of radius capital R carries uniform surface charge density of sigma per unit area. It is made of two hemispherical shells held together by pressing them with force F. So F is proportional to. So here a uniformly charged thin spherical shell of radius R carries uniform surface charge density sigma. So radius R, surface charge density is sigma. Sigma is per unit area they are telling. It is made of two spherical shells held together by pressing them with a force F. Then F will be proportional to. So a spherical shell is made of two hemispherical shells held together by press. So this is two hemispherical spheres which are pressing together by a force F. So one force is here, one force is here. Okay, so its radius is R. It is having surface charge density per unit area. Okay, we should find out the force. Force is proportional to which one? This is the question. So here we can find out the force. Force is equal to Q into E. Okay, what will be the electric field for this hemispherical shell? For a spherical shell, we got on the surface E will be equal to sigma by epsilon 0. This one in last one of the videos we did, right? Last video we did this. E is equal to sigma by epsilon 0. Then for a hemispherical shell, if it is half of that spherical shell, E will be equal to sigma by 2 epsilon 0. Then what will be F? F is equal to sigma by 2 epsilon 0 into, what is Q here? Q will be equal to sigma. Before Q we can write down the equation for sigma. Sigma equals Q by S. Okay, so Q by 4 pi r square. What will be the S for the hemispherical shell? For a spherical shell, S is equal to 4 pi r square. Then for a hemispherical shell, S will be equal to 2 pi r square, right? So it is 2 pi r square. So Q we can write it as sigma into 2 pi r square. Right? So sigma into 2 pi r square. So 2 and 2 will get cancelled. Sigma square F is equal to pi sigma square r square divided by epsilon 0. So force is proportional to which one? Sigma square r square by epsilon 0. Clear? So I think this is useful for you, and one more thing you should keep that in mind. These three numericals are not at all enough for your JEE preparation. So this is just a help for you. This one I am just showing you that if you are trying, you can do. You should practice more numericals or more questions based on these. Okay, many worksheets are available in the net. Please utilize those questions, and in many sites it's available. It's free also, free to download. So please try to do that, and see, this is your career. You should decide. Okay, if you are really interested, you will do. I am sure about it. So if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.